Alright, hello everyone, it's Sachi back with my 7th video in this series of 35 videos, one for every question in a Physics C Mechanics multiple choice test. So, I'm going to read this question for you. So we have, it's a little bit hard to see from here, I'll move it in closer. We have figure 1 and figure 2. Figure 1 is before the collision, figure 2 is after the collision between these two carts. Let's get this centered, and let me read the problem. Two carts of equal mass are on a horizontal surface with negligible friction. Cart A is approaching cart B, which is at rest. Attached to cart B is a spring that is initially compressed. At the moment cart A collides with cart B, the spring is released and pushes on cart A. Here, let me include fig 2. So this is before the collision. Figure 2 is after. So A comes, hits cart B, and then they start to move away from each other as the spring is released. The spring is released and pushes on cart A, which correctly states what happens to the kinetic energy and momentum of the system as a result of the collision compared to those quantities before the collision. So we're looking at 1. Kinetic energy, 2. Momentum. So to talk about this problem, we've got to talk about what an external force is. So an external force, I don't have that much space, so I'm going to try to save room in what I'm writing. An internal force is something that's in the system. So we have the system defined as these two carts, like on this horizontal surface. And an external force is energy that is introduced into the system. So momentum is something that is conserved only in a closed system where there is no additional energy being inputted into the system. Those are our definitions for now. Kinetic energy. Let's just look at where the energy is stored in the system initially. So initially, this is moving. This is kinetic energy. So Ke. Let's write the initial kinetic energy equation. So we're starting with it's moving. So it's 1/2 mv squared, and we have no energy here. We're saying the compressed spring is we're not counting that energy. We're going to count that as energy introduced to the system for now. And then at the end, the energy we have is we have two velocities moving away. So and they have the same masses. So 1/2 mass times velocity 1 squared plus 1/2 mass times velocity 2 squared. Yeah. But what we're looking at here is that with kinetic energy, whether it's increasing or staying the same, the kinetic energy of the system is initially just in cart A. And then once this spring is released, the potential energy that is stored in the spring is introduced into the system, which results in more kinetic energy. So we know that the kinetic energy is not going to stay the same. It's going to increase. Now we're narrowed it down to A, B, and C. So this is where it gets a little bit difficult. We're looking at momentum. So that's what we're looking at now. We're looking at these three. So is the momentum going to decrease? Is it going to stay the same, or will it increase in this system? Let's go back to what we talked about at the start of the video, an external force. An external force is going to be energy introduced into the system in the form of this spring that is released and pushes on cart A. So at the start, when the energy in the spring isn't affecting the system at all, when it's stored in potential energy, and then cart A hits cart B, this energy is released into the system. It's an external energy source. So that means momentum cannot be conserved because there's external energy. That's just the definition of momentum. So let's get rid of stays the same. Now, is the momentum in the system going to increase or decrease? Well, if we're adding energy, the momentum isn't going to decrease. That doesn't make sense. So we've already figured out that it's C. Both kinetic energy and momentum are going to increase in this system because of this. The spring is the key in this problem. The potential energy stored in the spring as an external force, once introduced into the system, increases the kinetic energy, and because it is an external force and not a force that is originally included in the problem, is also going to increase the momentum as well. Thank you for watching. Let me know if you have any comments, questions, concerns, and check back in for problem number 8.